Hello, space fans. Welcome back to Space Store Roundup. In the house once again, we have Nick Howes and Terry Moseley. How are you guys doing?
Hi,
Pretty
fine.
good.
Good to be back.
Awesome.
Pretty good.
Really nice to have you. Thank you so much for joining us on another Roundup on Tuesday evening. This is where we bring you the latest and greatest of space news. So tighten your seatbelts. We're in for another incredible Roundup. I'll hand over to Nick Howes and Terry Moseley. As ever, if you guys have any questions, leave them in the comment section below and we'll try and get to them at the end. I hope you guys enjoy it.
Cool. Cheers, Latch. Just a big up to the Space Store team for actually putting this one together tonight, because I know they've been driving all over the country. And Latch literally got here about 2 minutes before we're due on air. So big up on that one. No, it's really, really cool. What a momentous week, Terry. Been amazing. Politically, wow.
Politically and up in space too.
Indeed, indeed. So we're going to kind of kick off tonight's show with that. We're not going to talk about the whys, wheres and wherefores of the Four Seasons car park in Philadelphia and that incredible press release that happened there. We are, however, as this is a space show, going to talk about Jim Bridenstine. So we heard the news literally in the last 24 hours that sadly Jim Bridenstine was going to step down as NASA administrator. Terry, thoughts on this one?
Yep, he's very young. He's only 45. He was very much a Trump appointee and relatively recent. It was only in 2018, but he has sort of strong Republican connections. He's from Oklahoma. There's no reason why he couldn't have stayed on, provided that Biden was prepared to keep him. But I think, if you take a statement at face value, he says basically that whoever is heading NASA has to have the full confidence of the president and vice versa. And he said, I'm not the person to be in that position. Now, I have no idea whether Biden would have been happy to keep him or not. He certainly wasn't doing a bad job. And politics shouldn't come into NASA, but inevitably it does. It comes into almost everything. The one thing that maybe he might have thought that would be an issue would be Trump's great sort of plans for a space force, which Biden may not agree with at all. That's the only thing that's sort of a really active issue at the moment. Most of the other things that are up in space are being planned, are well along the development stage. So that was the only thing that occurred to me, but that's just my own personal thought. But he'll probably still have left his mark, and is a few. He's not going to actually resign until Biden takes over on, I think it's the 20th of January. So maybe he'll have a few little things to do and say before he goes.
That's the thing. Bridenstine's appointment, I remember when it happened. So he's been just under 2.5 years in the job as NASA administrator. And I remember when he was appointed, I was one of the first people, along with thousands of others, who are like, this is not right. This is a typical Trump appointee. And, for all of, I'm not going to get into the politics if you vote Republican or Democrat. I don't really care. What you need is competency in the job and somebody who's really capable of the job. And some of the appointments that Trump had made were largely ridiculous. You only had to look at the revolving door at the White House, basically, to see just how many people were coming in and out. Bridenstine was one of those that people said, well, hold on, he's a climate change denier, so he's not really into the science, and he's a businessman. He's a very staunch Republican and came mostly from a kind of business background. Now, it became very evident, I think, very quickly that he was more cast in the role of James Webb. Now, if some of the older listeners will maybe not remember James Webb, will know of it from the telescope. Obviously, NASA are about to launch a James Webb telescope in the next few years to kind of succeed the Hubble, as it were, as an infrared telescope. But James Webb was the NASA administrator that basically got NASA through the Apollo program, or most of the Apollo program. And again, very kind of politically motivated appointment, really strong businessman, but did an incredible job. And I think Bridenstine, for whatever you believe about the politics, etc., and obviously he's got his issues and his faults in terms of possibly some of his beliefs that many people may not agree with, but he did a good job. Nobody can say he didn't do a good job. And even staunch Democrat friends of mine have said, this is a real shame, because they were all hoping that he was going to stay on, because it would have shown phenomenal, probably bipartisan intent. Had Biden said, okay, this guy's a Republican, but he's doing a good job, so let's keep him in post, keep him in office. He was driving a lot of what was happening with Artemis, and that was possibly a good thing, possibly a bad thing. You know, Artemis is not going to hit the moon by 2024. Everybody's kind of saying that beneath the table, as it were. Nobody really wants to admit it at the moment. Possibly 2026, 27, we may see boots on the moon again. Be fantastic. But I think one of the main criticisms with Bridenstine, is his focus on human spaceflight as opposed to exploration work. And I'm in two minds about this as well. I think he was very geared up to generating a lot of interest in everything NASA were doing, you know, from the Juno mission to Jupiter, you know, what New Horizons did a few years ago with the flyby and the ongoing research that they're doing. I don't think he was totally focused on the moon. Obviously, Trump had said, we've got to get back to the moon by 2024. You know, whether or not that happens now, who knows? Because obviously we saw what happened with Obama, with Constellation being cancelled, etc. So it'll be really, I think, interesting to see who gets the job. And I think it's a big shame that Bridenstine's going. But you've got people like Laurie Garver, who's extremely well respected, broad scientific background, broad knowledge there. Obviously, a female appointee. You look at Kamala Harris and the fact that she's now the first female VP in US history. So maybe in keeping with Biden's broad remit to be as diverse as possible, there will be a female person. We've obviously had a person of color, you know, with Charlie Bolden as NASA administrator in the past. So it could be that Laurie Garver does get the gig. Who knows at the moment? We won't know, as Terry said, until next January. But it's an interesting one to follow this, I think.
Yeah, I think the other thing about Bridenstine, he may well realize that the 2024 target for Artemis is not really achievable, and he wouldn't want to be seen as in charge whenever they fail to meet that target. Certainly if Trump had been re-elected and Trump was adamant that they were going to get boots on the moon again by 2024, and if they failed to do that, well, as we know, Trump doesn't like losers. So that might have been something at the back of his mind. He may even have another very good offer to go to that he's not revealing yet. We simply don't know. But the thing about Laurie Garver, not only is she a huge amount of experience in various aspects of the space industry, quite apart from NASA, she was deputy to Charlie Bolden. But she's been involved on the business side as well. She was head of the Airline Pilots Association, which would be sort of very much a commercially based organization, not connected with research. So she has both business acumen and she has tremendous experience in the space industry. And she also worked deeply on the political side. She was advisor to Obama on the transition to when he became president on the NASA side of things. So I would love to see her in that position. I think she'd do an excellent job.
I think it's not a shoe-in, but she would seem to be the most logical candidate to take over from Bridenstine. So, yeah. But until January the 20th, and that is obviously based upon all sorts of issues that everybody knows are going on at the moment. There's all sorts of legal actions, legal cases, etc. All I want to hopefully see is the continuation of really good science. NASA have come back, as it were. They had a bit of a hiatus and a bit of a lull, or as Trump said, they were dead. But they had a genuine hiatus probably in the post-shuttle era. Some of the robotic missions obviously have been carrying them forward. It'd be great to see that continue now. And if Bridenstine does leave a legacy, I would hope it's the fact that he really was, a very keen advocate of a return of human exploration and human spaceflight. So, let's watch this space.
Yeah, just going to say we can't rule out the present deputy director, of course, at the moment.
Absolutely. This is the thing with NASA. You've got so many great potential candidates across so many different disciplines. Who knows? Bridenstine was completely out of the blue. Nobody expected that. So we shall just see and see where it goes with this. It could be an ex-astronaut, as it was with Charlie Bolden. So who knows? On to our next story. So this one we've covered in the past, but there's some really exciting stuff coming up with Rocket Lab. So Rocket Lab are a US-based company, but predominantly do a lot of their launches out of New Zealand. Really a good model for kind of where the UK is trying to head in terms of exploration and spaceflight. I was on a call earlier today with the UK Space Agency and UK government and the Scottish governments and Highlands and Islands talking about this. And, you know, the plan now that Lockheed Martin have got to move up to Shetland, taken away from Sutherland. So you've got Orbex now with Sutherland. But Rocket Lab continues to just push forward, as it were. Yep. They've only had one launch failure of all their missions so far. And earlier this year, they did what's called a HELO, helicopter-based recovery test, where they took a first stage and effectively dropped it and then caught it with a helicopter. Now, you may think this is complete madness, but it's been done for decades. I mean, this was done with military payloads all through the Cold War, from space, from orbit, when satellites didn't have the capability really to transmit data to the ground as well as they do now. You'd have film canisters literally dropped out of orbit from spacecraft and captured by flying aircraft in giant nets. So it's not a case that this hasn't been done before. It has been done. There's a test. The first test is essentially what Peter Beck and Rocket Labs are doing, is really kind of pushing forward with it's incremental testing, as it were, incremental step testing, very similar to Jeff Bezos's approach. Unlike SpaceX, which is like all or bust methodology, again, with rigorous testing, but they've got a much faster timeline. Rocket Labs tend to do things in a nice, small incremental steps. So the first one's going to be a splashdown test where they're going to do recovery from the ocean, and then, who knows, potentially mid-air helicopter recoveries. How this is going to work off the coast of Scotland with the high winds and the jet stream, yes. I do not know. That's going to be entertaining to see if Lockheed pull that one off. But that's the key thing here. It's recovery. And SpaceX now are dominating the space industry because their capability to recover most of their spacecraft. They're recovering the fairings in nets. They're doing full recovery of the first stage, almost routine now, landing on the barge. Obviously, I'm Sure I Still Love You and the other barge out in the Atlantic Ocean, and obviously dual cores landing at the Cape. They've done it already. So everybody's got to compete with this. And if you don't have that recovery, re-landing capability, this is the next best option. I don't know if you got any thoughts on this one, Terry?
Yeah, I don't know the details of this, and maybe they're ahead of me, but if I was planning that, I would have two helicopters, one at, say, 3,000 feet, and if it misses, you have another one down underneath to have another go at it. That seems so obvious that probably they already have that in mind. But yeah, it's basically, you get one chance at it unless you have the two helicopters. You know, if you miss it the first time, you're not going to be able to swoop down underneath and get it on a second chance. So that would be my thought. But yeah, it makes sense. I mean, it is the way forward now, is to reuse as much stuff as possible and keep the cost down. And there are various ways of doing it. And this one, as you say, has been tried many times, right from, as you say, way back in the early days of the Cold War, when they were recovering film canisters. Always wondered if one of the other aircraft got in first and nabbed one of the Russian ones on the way down, or vice versa. But anyway, that's getting into politics again.
Yeah, it's fun actually. When I've flown a few aircraft a few years ago, Cessnas, and while we were landing, it was an airport in North London. There was an old MiG-15 coming into land, and you're just looking at it thinking, really, do people really used to fly those? But it's going to be interesting, and I love everything Peter Beck does. He's really a visionary in the same mold that, you know, people like Musk and Bezos are. He's just doing it in a slightly more understated way, smaller launch site. But as I said, if you want to see what's going to be happening in the UK in the coming few years, all being well, and Scotland don't devolve, and then we don't have a UK, as it were, in terms of a space agency up in Scotland as well, that's going to be interesting. If that happens, given the political events of the last few weeks, who knows what's going to happen. But it'd be really interesting to see. And if you want to see, as I said, what's really going to be happening in the UK, just look at what Rocket Labs are doing in New Zealand. It's a very good model for it. On to our next story. So this is a good one. Harry.
Right, Virgin Galactic, they have been almost in the shadows from Musk and Bezos recently, but they were the first ones really in terms of the private enterprises to talk about getting people into space, or at least the edge of space, up above the Kármán line, which is a sort of an arbitrary line. It's roughly 100 kilometers, 62 miles, and it is arbitrarily defined as the edge of space, whereas actually our atmosphere extends a lot higher up than that, but it's very tenuous at that point. Now, they have done numerous launches from the aircraft there that you see, White Knight, which basically takes the spaceship up to an altitude of 40,000 feet or so, and then drops it, and that reduces a lot of the fuel load to try and get the spacecraft off as it was launching from the ground itself. It's one of many ways to try and get space launch done more economically. So up until now, they've done their launches from the Mojave Desert in California. They're now moving to Spaceport America in New Mexico, and that's where they're going to do all their future manned launches. Crewed launches, I should say. They hope to do the next one later this month, between November the 19th and 23rd. And assuming that that's successful, then Richard Branson himself is going to go up on a subsequent flight. And if that all works well, then it's open to the paying customers. It's quite a fancy spacecraft. It's obviously not designed to go right up into orbit, just to go into very high altitude and come down and then glide back and land on a runway again. But it'll take up to 6 passengers, and the view is supposed to be the main attraction for this. You get each passenger gets a nice circular window, and there'll be windows up above your head as well, so we can see what's up above in the sky. And even on this next launch, NASA is going to send along some science experiments for a ride. I don't know if it's a free ride or not, but anytime something goes up into space, you may as well take advantage of it for whatever, say, weightless conditions you need. So I'll watch this with great interest. I have a personal friend who has had a ticket booked with Virgin Galactic from way, way back, I think almost as soon as they were first put on the market. And he's been chewing his nails ever since, with frustration at every subsequent delay. Of course, they had an actual tragedy of a death, but they've learned from that. And it looks now as if they're on the home straight, and Branson himself hopes to actually be up in space before the end of the year, and I can only wish him luck.
It's interesting what you're saying. I mean, obviously, this project's been going for some time, and there's some good comments already coming in the chat about the kind of length of these projects. I mean, a lot of the robotic missions, they're decades long. I remember watching the Sky at Night in the 80s when they were talking about Cassini-Huygens, years before, anything was kind of really viable and any metal was cut, as it were. And I know the same from working in the defense industry, how long these projects take. And this was unveiled really in 2004. So it's 16 years in the making now. Your friend, Terry, is one of about 570 other people who are still apparently booked on these $200,000 tickets. And that's the thing, it's a 2.5-hour flight, but you're only a few minutes in space, as it were. And then the argument of, is it space? The Kármán line, as you said, you're at 100 kilometers, 62 miles. This isn't going up that high. This isn't even going as high as some of the X-15s flew in the 1960s. So the qualification for astronaut wings, yes, the nominal line they are crossing. Hopefully by the time it becomes an almost regular occurrence, possibly they'll go even higher. Spaceship 3, which is the one that's planned for their orbital projections, where they're looking at point-to-point transfers for really improving what we're doing in terms of point-to-point transfer for aircraft and making it a lot more fuel efficient. That'll be interesting as well to watch. The SRLV program that you mentioned, which is the NASA program to put suborbital kind of payloads in this, again, it's really good from a testing perspective, and the fact that you can pack so much into it. So if you can take 6 passengers, all the well. My issue with this is those 6 passengers are going to be pulling between 6 and 8 Gs coming down, and it's not going to be pleasant. If you've ever been in the Vomit Comet, and I've got friends who've been in the Vomit Comet, it's called the Vomit Comet for a reason. So it's going to be really interesting watching all these people who've paid upwards of $200,000, plus all the other expenses of getting to the Mojave Spaceport, etc., and all the other associated costs, to spend 6 to 15 minutes, depending on how long it stays up there, floating around. Fantastic experience that's going to be, but yeah, it could be a bit icky. So it's going to be a good one to watch. What I love about this, and what I love about everything that Bezos is doing, that Virgin Galactic are doing, and Virgin Orbit are doing, and SpaceX are doing, is it's getting people looking at space again. It's getting the average person in the street really excited about the space sector and science and engineering again, which we haven't had in a long time. The nerds of us, the kind of space community, we follow everything that happens and we follow all the robotic missions, etc. But to the average person in the street, it's human exploration. And there was a massive debate about this. And I got really quite cross with Professor Lord Rees, the Astronomer Royal, because Lord Rees has been banging on for years about we don't need human exploration, blah, 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 blah. It's too expensive. It's this, it's that. We do need human exploration, because if we didn't have human exploration in the late 1400s, then Columbus wouldn't have discovered, rediscovered, North America or the Americas. It's innate in the human spirit. You know, people get excited about human spaceflight. People got excited about Tim Peake. People get excited about, you know, Neil Armstrong. You ask 100 people in the street who the first person on the moon was, they'll say Neil Armstrong. You ask them what the first robot was to visit Jupiter, they won't know. I mean, that came up in a space quiz that I was in last week. What's the only spacecraft to visit Neptune? It's Voyager 2. You ask 100 people in the street, they won't even know what Voyager is, let alone Voyager 2. So it's interesting, and hopefully, you know, it's a sexy looking plane as well, don't get me wrong.
Yep.
This is really Scale Composites know what they're doing. Bert Rattan's
Yep.
team, they really have cracked this one. The feathered approach, which obviously led to that tragedy with a missed deployment in 2014, killing the co-pilot, which was a real tragedy and obviously set Virgin back quite some time. That's another thing that we need to get around as well. You know, if we have a tragedy in space, we need to just learn a lesson and move forward. We can't stop everything just because something goes wrong. You've got to move forward and move forward at pace. And this is where SpaceX are cleaning up, because they blow up stuff, they move on. They blow more stuff up, they move on. Musk has even said, the SN8 test, which we'll probably cover in the next show, that's happening in the next few weeks, where it actually looks like a rocket, and it's going to go with multiple Raptor engines, and it's going to belly flop its way down. He's not expecting it to work. He didn't expect Falcon Heavy to work. When it did, he ran out of the SpaceX mission control like a 5-year-old in a sweet shop. It was amazing to watch. And that's the kind of thing that we need, the kind of passion that we need in the space sector. And, all power to them. I think this is again, one to watch. Really interesting. Brings us on to our next story quite nicely. Terry, I'll let you lead on Bennu on this one.
Right.
You've got a Bennu thing going.
Yeah, Bennu is the asteroid that was visited by OSIRIS-REx, and so far very successfully. It's only about 1,000 feet in diameter, so it's pretty small. Very, very hard to orbit it because it actually has practically zero gravitational field. But OSIRIS-REx orbited, photographed it, studied it in great detail to try and find a suitable landing spot, went down, collected some samples very successfully, more than they expected, and has got the samples and retreated to a safe distance, stowed the samples safely, and very shortly it will be starting its return journey back to Earth with those samples. But during the 2 years or so that OSIRIS-REx was orbiting Bennu, it was obviously taking all sorts of measurements and studying it in every way possible. And one of the things that they found was that little bits and pieces of it were flying off as it was rotating. It rotates once every 4 hours on its axis. And little bits were flying off, and even though it has a tiny gravitational field, a few of them were falling back down again onto the surface. And from studying that, the motions of these particles, the scientists have worked out that Bennu is probably hollow. And that's because basically it's not a solid body, it's a collection, what they call a rubble pile, a collection of various sizes and shapes of rocks and pebbles and smaller particles right down to dust. And of course, as something rotates, it tries to fling stuff outwards from centrifugal force. So by studying the overall gravitational field and the density and the rate at which these particles came up and fell back down again, they've concluded that Bennu has a hole in the middle, basically, about the size of a couple of football fields. And because it's spinning, they reckon that basically the material is being gradually pushed out towards the edge, and eventually they reckon in about 1 million years or so it's liable to spin itself to pieces. Now, I was reading up on this, and there's something that I can't find anybody addressing. We know why it's spinning up due to the York effect. We needn't go into the details of that too much. Other factors as well. But what about conservation of angular momentum? As material is pushed from the center towards the edges, it basically will try and slow down the spinning up, just like an ice skater spinning on the skates. If he or she wants to slow down, they put their arms out. Conservation of angular momentum reduces speed. And if they want to speed up again, they pull their arms in close to their body again. So there's two opposing factors there. And the conservation of angular momentum is a pretty strong force. And as more and more material gets shifted from the center out towards the outer surface, that conservation of angular momentum is going to be a greater and greater effect. I read all the papers on this that I can see, I can find, and I can't see anybody addressing that. So what do you think, Nick?
I don't know. It is an interesting one. You talk about rubble piles as well, because there's obviously completely unrelated story to this one, but Tunguska is one of the theories of what the Tunguska event was, but it was a rubble pile asteroid. So I think that would potentially, some of the sample return on this could give us some more evidence in terms of the research in that direction as well. As for the Yorps effect, I mean, it leads on quite nicely actually to our other asteroid that we're going to talk about here, which is Apophis. Now, Apophis was this kind of 340-meter wide asteroid that flew by some years ago, and everyone got in a bit of a panic, and the various newspapers in the UK, the more sensationalist tabloids were saying, oh, it's going to come back and hit us. And then a lot of scientific analysis on the orbital dynamics of it and the orbits of it basically showed that that wasn't going to happen, or the chances of it happening were down to, I think, 1 in 150,000. So there's a thing called the Torino scale, which basically measures the likelihood of a large planetesimal impact on the Earth, and its Torino scale value just dropped off literally a crevasse. Anyway, there's been some more recent updated observations of this, which look at this Yorps effect, so the Yarkovsky effect or Yorps effect. Basically, what you've got is incident radiation, light radiation from the sun, which will affect the rotation rate and the orbital it'll give a kind of push to objects in orbit. Now, factoring this in with some of the most up-to-date data and some of the observations from the Subaru telescope, which is this enormous Japanese telescope, have led us to kind of increase that risk again. So it's not that we're out of the woods completely, as it were, which we were with the old observations. It's now looking potentially like this one has to be tracked and observed with a lot more detail, because by 2068, which is a potential threat timescale for this, so we've got a long time to potentially deal with it. And we talked about risk mitigation and how you would deal with these kind of short-term or long-term events. We've got enough time to deal with this one, but by 2068, if these orbital observations carry on and the refinement of the orbit continues, potentially we could have a 340-meter wide asteroid impact in the Earth. Now, putting that into context, Meteor Crater, erroneously named, but the Barringer Crater in Arizona was a 50-meter wide object, which carved out something nearly a mile wide, several hundred feet deep, 50,000 years ago in a matter of like half a second. There was a really interesting thing just published in the papers today showing all the different meteorite crater impacts all over the Earth. We've obviously been bombarded for thousands of years, and obviously in human history we've known about several events that have been well documented. Russia, Tunguska in 1908, something airburst and flatlined hundreds of square miles of forest. We had Sokotoline in the mid-1940s. We've had all sorts of different events. The most recent obviously being Chelyabinsk, which was 17 meters wide, airburst again, essentially a kinetic energy of several atomic bombs. So something 340 meters wide. If you go on the online impact calculator and put in an object that's made out of potentially dense rock, it could have an iron core, but potentially put in dense rock, 340 meters wide, hitting with any kind of velocity you want to kind of imagine, you're looking at a complete city destroyer, at the very least. I mean, if something that size were to hit a densely populated urban region, everyone would die. So it's something that we do need to really consider, and I've been saying this in pretty much every show we've done so far. Yep. It's not just these ones, it's the other threats, like the comets. It's the ones that the 5% that we don't know about, because NASA said, oh, we catalogued, we believe 95% of all asteroids above 1 kilometer. That's great. There's still 5% out there. And when you've got 800,000 in the asteroid belt, you've got 800 million to 800 billion in the Kuiper belt, and you've got in the billions to trillions in the Oort cloud. Who knows? We've got objects that we really need to keep a handle on. And this kind of links back into our ability to observe the skies and our ability to do anything about it.
Yep.
Which ties back into...
Sorry.
Yeah, it ties back into Mr. Musk.
Yeah. Just sort of, it always blows my mind just how much progress there is in astronomy. the way they have measured this, they worked out that the change in the orbit of Apophis is only 557 feet per year. And this is something that's millions of miles away. As you say, the Subaru telescope is a superb, big, powerful telescope and an exceptionally good observing site. But just to work out, to give you an idea of how accurately it can measure the change in the orbital motion, they measured the change, the position to an accuracy of 10 milliarc seconds. Now, that probably doesn't mean very much to most people, but to give you an idea, it is 1/2 millionth of the amount that the second hand moves on a clock per second. So your clock goes, or your second hand goes one little click every second, and that's 6 degrees. So if you work it out, what they have measured is 1/2 millionth of that size of an angular change, and that blows my mind.
I'll go on better then, Terry. That is a mind-blowing statistic. Do not get me wrong. Please don't think I'm dissing the Subaru telescope in any way. But when I was at the European Space Agency, I was working for ESA probably about 10 years ago now, and we were working on the LISA Pathfinder and the LISA mission, which is the large kind of interferometer that they're going to put up in space. So similar to LIGO and the detection of gravity waves on Earth. But these things, essentially what they were going to do was fly, and still planning to fly, 2 spacecraft separated by 1 million+ kilometers in space, and inside these 2 spacecraft they have perfectly polished beryllium cubes which are free floating inside the spacecraft. And the idea is that you fire a laser between these 2 spacecraft and measure the deflection angle of the beryllium cube when a gravity wave passes through that space between the 2 spacecraft. The angular measurement on that is able to basically, I mean, initially when they were testing it, they said they could do the width of your fingernail on the moon, right? Now it turns out it's the width of your hand at Proxima Centauri. So the angular,
4 light years away.
These kind of angular separations are literally insane. The measurement accuracy now we've got, and don't forget, Subaru is a ground-based telescope. So Subaru is susceptible to anything in terms of the Earth's motion, in terms of, it's got to be completely isolated from any earthquakes or anything like that. Then you're punching through 100 kilometers of munge above our heads in terms of the atmosphere. So, the adaptive optics systems, and I was at Palomar working on the their Palm adaptive optics system years ago, when we were commissioning some of the Oxford instruments, the Swift instrument up on Palomar. Very fortunate to be up there at the time when that was being done, looking at that thing and thinking, this is astonishing. Being able to bend the mirror that rapidly. As I said, it goes back to, we talk about this a lot, but the threat of something like a Kessler scale event from these mega constellations, and incorrectly named, but we'll go with the term, these mega constellations, isn't just the effect it's going to have on astronomy, and that's optical astronomy, which has already been shown, radio astronomy, which is an absolute nightmare. The band 5B for the SKA Telescope is literally going to be wiped out by Starlink, etc. So we don't want to see that happen. But if this occurs in low Earth orbit and we do lose the ability to launch mitigation strategies against an incoming threat, and that could be, utilizing the Orps effect for a long duration one, or, we're not going to blow them out of the sky with missiles. There's going to have to be a better way. We talked about this in previous shows. There are potentially better ways of dealing with it. But if we lose that capability, that's going to be really bad for the planet, because it's one of the few things, we've heard this week the fantastic news from Pfizer about the vaccine for COVID, and hopefully within the next 6 to 12 months, the world will be a better place in terms of, we'll all have a capability to get back to some semblance of normality again. Fantastic. If an asteroid's coming our way and it's large scale, we have nothing that can deal with that right now. And they can talk about it, they can war game it, they can shoot tiny little rockets at Didymos and Didymoon, etc., and measure it. It's fantastic. But if something's coming our way in the next 10 to 50 years, we have nothing to solve this problem. So let's hope that Starship works, and at least then we've got something large enough that could potentially maybe do something, land on it and fire some thrusters. Who knows? But we've got to keep an eye on this. And Apophis now has just gone up a few notches. It's not, it's not a direct.
Not significant.
No, it's not a deep impact. We're not talking about, get Bruce Willis out, but it's one of those things that we need to keep an eye on. Definitely, for sure.
Yep.
So finally, on our show tonight, look up. What are we watching out for this week? Well, I know I've been looking at the moon. It was fantastic looking at Clavius after the recent discovery, in inverted commas, of water on the lunar surface in the form of crystalline, captured crystals inside glass beads. Really fascinating. Mars has been spectacular, and some of the images. Oh,
I know Chris Peach or Damien Peach,
Damien.
sorry.
But now here I've got an issue with this. I love Damien. I absolutely love Damo. Damo's a brilliant imager. My issue now is that we now have, in inverted commas, amateur astronomers. Damien would always consider himself to be an amateur astronomer, and same with Thierry Legault, etc. These are the best amateur imagers in the world. Thierry Legault's work on imaging the space station. He managed to capture astronaut on EVA from the ground.
I have a copy of that.
Yeah, it's just amazing. And Damo's work, some of the stuff he's done from Barbados with a C-14 in the past, again, absolutely beautiful. So no knocking that at all. My issue with it now is that him and Thierry Legault are both using 1 meter class instruments out of Chile. They're using the Chile scope.
Yeah.
1 meter is not a backyard telescope. And the images that are coming out of Mars, I saw Paul Hees, he's a great guy based down in Australia, with a genuine backyard telescope, taking some staggering images of Mars. And then this image from Thierry Legault came up. It's like, this is the greatest thing I've ever seen in terms of ground-based images of Mars. Really was stunning. But then you look at the instrumentation, and this is research-grade instrumentation. I used to have access, for 6-7 years, I was on Faulkes Telescope, which is a 2 meter class instrument almost every day, doing like research astronomy in terms of comets and asteroids, etc. And it was fantastic. We weren't really taking pretty pictures. I think that's a complete waste of time on a telescope of that kind of caliber. It's a research-grade telescope for a reason. But taking images of Mars, and they are spectacular, and I'm sure that the images of Jupiter, etc., are going to be really good from a scientific point of view. But it's then you publish these images, and the expectations for the public, like,
I know
you can do this as an amateur. You can if you've got access to a $2 million telescope. Of course you can. But a C-14 is a $4,000-5,000 telescope, £4,000 that is within the reach of people, humans, average people. Not everyone's going to spend that much on a telescope, but you can. People spend that much on a car. If you want to spend a lot on a telescope, you can. And I know there's some great images where you are in Ireland, Terry, that have been using C-14s for years. Obviously, Damien flies down to Barbados because the laminar flow at Barbados is astonishing. I've just got a little bit of a bee in my bonnet about the whole imaging and where it's heading now, because it's not true to the amateur spirit. It's not true to the William Herschel, although look at Herschel and the stuff he was building with the gigantic speculum mirrors. So anyway, rant over. Back to where we're looking at.
I was going to do a segue from Subaru, which of course is the Japanese word for Pleiades, and the Pleiades are coming up very nicely in the evening now. The most beautiful and spectacular and brightest star cluster in the whole sky, north or south. And they always signal sort of this time of year, you're well into autumn, you're approaching winter, but they're beautiful. Lovely to look at just with the naked eye, but if you have a pair of good binoculars, have a look. If you telescope and get a wide field eyepiece in, it's just absolutely fabulous. So they're there at this time every year, but some things that are just particularly topical. Mercury, the most difficult of all the planets to spot, with the possible exception of Uranus. You always know where it is. You probably need binoculars to find it. But Mercury is always so close to the sun in the sky that it's quite hard to see. And it appears either in the evening sky, and for us in the Northern Hemisphere, the best time to see that is in the spring. But in the autumn, the best time to see it is in the morning, and it's very nicely placed at the moment in the morning sky. You will also see Venus, which is by far the brightest star-like object in the sky, totally unmistakable. It's well up in the mornings now, just before sunrise. And if you look just a little bit to the lower left of Venus, you'll find over the next 2 weeks or so, another little bright star-like object, and that is Mercury, the closest planet of the Sun. It's actually quite bright. It's second only to Sirius in terms of brightness relative to the stars, but because it's slowed down and because you only see it in the morning twilight, it doesn't appear that bright, but actually it is brighter than all the stars that we see apart from Sirius. Now, if you still can't find it, your best bet is on the 13th of November, whenever Venus and the waning crescent moon and Mercury will be in a nice little curved line. So you can't miss the moon, you can't miss Venus. So you find Venus, below left of that will be the moon, and below left of that will be Mercury. Hopefully it's clear that morning. If not, the moon will move out of the way fairly quickly, but for the next 2 weeks or so, Mercury will be visible in the morning sky below left of Venus. And two other things to look out for in the next 10 days or so. Two minor but not negligible meteor showers. First of all, the Taurids, which are reaching maximum in the next couple of days. And as the name implies, the meteors come from the constellation Taurus, quite close to the Pleiades. And then on the 16th, 17th, 18th of November, probably 17th, 18th is best, the Leonids, which come from the constellation of Leo. And they only rise, the radiant for those meteors only rises later in the night. The ISS, the International Space Station, is out of the way at the moment. We'll not see it until the 22nd of November, when it starts another series of evening passes. We'll say more about that next time. But also keep your eye on Jupiter and Saturn, which are low down in the southwest after sunset. They are getting closer and closer and closer together. And on the 21st of December, we're going to have the best conjunction of the two biggest planets in the solar system for lifetime. So keep an eye on them and watch them getting closer and closer together. So those are the main things to look out for at the moment.
Definitely. Going back to Mercury, it's really a lot of fun talking to people like Susie Imber, who's based out of Leicester University, and she's one of the instrumentation engineers working on Bepi Colombo. And if you're looking obviously in that direction towards Mercury and Venus, just think about this as well. You've got a spacecraft that's literally just on a flyby of Venus, in Bepi Colombo, that's doing multiple gravitational flybys to basically get it into the correct orbit for Mercury. So people say, oh, why don't they just send it there straight away? Yeah, it's a deceleration problem. You've got to get the orbits correct because you want to go into orbit around Mercury, and obviously they've got issues with heat and thermal issues, blah, 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 all sorts. But if you look towards that direction, just remember the fact that there is a spacecraft that's just flown, as I said, by Venus and looked for this phosphine event on the cloud decks of Venus, which is really interesting. And there were all sorts of debates, I know, in the Bepi Colombo instrumentation team as to whether or not they could even make that detection. But when it gets to Mercury, this is going to really transform our observations of Mercury. We've had, several missions to Mercury in the past, with the, going back to the Mariner days even, but it's going to be one of those things that I think this time we're going to get so much of a detailed view of the closest planet into the sun, and hopefully work out if a little meteorite that I own, NWA 4355, 4325, can't remember the number right now, is actually a piece of Mercury, because it's one of the only ones that people think could have potentially come off Mercury, which the orbital dynamics for that blows my mind, because you think about the impact it's coming out of the solar system. But definitely. And again, with Jupiter and Saturn, again, you've just got to remember what these things have been visited by all through the decades. And Voyager this week, the Deep Space Network down at Parkes, which has now been renamed the Parkes Observatory in Australia, very famous obviously is The Dish, although that film was there was a lot of fiction in that film. It's amazing to think that we've had spacecraft now visiting the planets for nearly 60 years. The first impact on the moon, first crash landing on the moon was a Russian spacecraft like 60 years ago practically. It's just astonishing. And you think that Voyager has just been recontacted by the Deep Space Network only in the last few days, because they had to literally strip down and overhaul the entire DSN in Australia, because obviously the galactic plane where Voyager 2 is right now, you can only really see it from the Southern Hemisphere telescopes. And the energy coming from that is just non-existent. It's just amazing. It really is. So I've got to say, I'm looking at the chat, huge thank you to the questions we've had tonight and some really nice comments. One from Ground-Based Space saying thank you for us, Terry, yeah, as well, definitely both of us, hopefully, inspiring them to take up an astronomy course with the Open University. So huge thank you. Yeah, it's really, really cool. And also apparently dropping Christmas hints with his wife for a nice new telescope. So I can say I've been there. I've been there. When I graduated my master's degree, my wife said to me, if you graduate, I will buy you a telescope because that's all you talk about. And she did. She was good to her word. And then it bankrupted me in terms of how much I've spent on observatories and stuff over the years. But and to Chris Parr, Chris is somebody I've known for a short while now. He's been putting in some great comments about robotic decadal studies and comments on Peter Beck. So definitely worth chatting, carrying on the chat on Twitter and on YouTube. Post the comments in either the Space Store's Twitter feed or on the YouTube channel. We'll try and get back to you on those. It's been a blast again tonight, hasn't it, Terry?
Yep. There's just one thing, Nick. They may well, and I hope they soon will, find a cure for COVID-19. They will never find a cure for something that you and I have both got, aperture fever. You're always wanting a bigger telescope.
Yeah. Absolutely, absolutely. Well, yeah, that is the problem. The thing is, it's an interesting point. A lot of people say, "What should I buy? What should I buy as my first telescope?" It's worth spending a little bit more. The mount is always more important than the optics. If you get a shoddy mount, it's going to put you off astronomy for life, because what's going to happen is you're going to point your telescope at something, anything other than the moon. The views aren't going to be that great, because what you see on the box that they print on the box are normally images from the Hubble. What you see when you look at something, even the Andromeda galaxy, which is the nearest large galaxy to us, is a fuzzy ball. So you don't really see much. The thing is, if you get a good telescope mount and you hone your eyes, that's the other thing. Keep it in a cool place. Make sure that it's not kept in the house at night. If you've got a garage, obviously keep it in there so it stays nice and cool, so the optics kind of cool down. And if you're looking up, looking up at the sky, just let your eyes adjust. Take the whole thing in. Spend time out there. And yes, you will probably want to get into imaging, and you probably want to get cameras, and you'll end up spending budget. If you're going to get into imaging, budget yourself £2,000, $3,000, $2,500 minimum if you want to get serious about imaging. So that's just a pointer. But in terms of good telescopes for your kids for Christmas, we've got Christmas coming up, obviously, and Amazon are probably going to clean up for Christmas. So great, that's going to help fund the Jeff Bezos space program. Definitely do that. Yeah, make sure that you get a good telescope. We'll probably cover that actually closer to Christmas, but yeah, better mount the better. Huge fact. Oh, sorry, just before I hand back to Latch, again, a massive thanks to the Space Store team. They do some great work. They've got a great little shop. Apparently it's been turned into a kind of video production studio. They do fab stuff in VR. They got some fun stuff there as well. So if you're ever in the Oxford Didcot area, post-pandemic, hopefully when we've all been vaccinated, pop into the Space Store. Really nice team, great bunch of guys. And on that note, I'm going to hand back to Latch.
Brilliant. Thank you so much, Nick. And thank you, Terry, as well. Thank you, everyone who's tuned in tonight. I've absolutely loved looking at the comments. Thank you, Ground-Based Space. Thank you, Chris Parr. We absolutely love it when you guys get involved. And we're really starting to build a space community here. And we at Space Talk, of course, are absolutely loving that. So thank you, Nick and Terry, for doing such a wonderful job once again. For those of you watching this on catch up, remember you can browse through our playlist of all the previous roundups we've had. I think this is our 13th one, so we're constantly going every other Tuesday at 7:30. Our next one, as it shows on your screen now, will be in 2 weeks' time on the 24th of November. So make sure you clear that date in your diary. We'll be live on YouTube, so join us then. And just one other thing, as a local business, Space Store, we've been doing everything we can over the last lockdown and this lockdown to keep growing what we do. And last Thursday, we launched our first GoFundMe campaign to keep Space Store on the map and keep bringing space to everyone, everywhere, every day. So if you want to help us out, even in the slightest, head over to our latest uploads on our YouTube channel, where Steve, our CEO, gave a little talk, and there's a link in the description which will take you to our GoFundMe page. So go help us out if you can. And once again, as Nick said, Space Tour is very much open for business to serve DIDCOT and beyond. We've actually changed our services into a click and collect, and we're also doing delivery, as we've always done, on all the gifts and merchandise we have, which is going to be perfect, out of this world Christmas gifts for anyone who's a space fan. So head over to spacetour.co. And if you're in and around the DIDCOT area, pop over, say hi to our team. And we're also doing takeaway on all of our food and drink. And we've got the best coffee in DIDCOT.
They do. They really do. I just want to say as well that we all do this as a voluntary basis. So Terry and I, I say this to Terry every time I speak to him. I mean, the guy is a legend in not only the Irish astronomical community, but globally. The guy's got an asteroid named after him. What more can I say? And an honour from the Queen. So let's put this into context here. Terry is an absolute. Terry is an absolute legend, and I love just chatting to him. Lots of people have said to me privately on Twitter or YouTube or whatever, have said, what a joy it is to listen to him and listen to him speak. And I just say, yeah, he is. He's an absolute wonder to work alongside. But we all do this, like this evening show every 2 weeks. It's a big effort from everybody. It's all voluntary. We're doing it for STEM. We're doing it for outreach, for science. And that's one of the things I absolutely love, talking to Stephen. It was one of the things when I first met Stephen down at the Harwell Space Centre, Harwell Space Cluster a few years ago now. And you can see the passion. You can see the passion in everything that he's doing. And yes, the store is the store, and we want to keep that going as well. But we are doing this, because we love doing it. And
for the love of it, yeah.
Yeah, we absolutely do this for the love of it. So hopefully everyone who listens to us either live or on catch up, and we try and do a lot of plugs on catch up and what have you. Hopefully you're enjoying it. Thank you so much for listening. Again, thanks to a great team.
And if I can get a word in, Nick, thank you for the kind words, and I'd say exactly the same about you.
No.
Okay.
That's why I didn't let you get a word in.
Cheers, everybody.
Cheers. Thank you very much.
Bye.
Thank you for tuning in, and we'll see you guys again this Thursday for our Space Talk on Thursday Night Live with Sarah Krudas. So make sure you tune in then.
Adios, amigos.
Bye, all.